Hi everyone. Good evening to all. Do let me know am I audible or not? Am I audible and visible to everybody? Do let me know in chat and tell me how's your coding journey is going on. You all of you are trying the solutions by yourself, trying to solve the similar question that we covered in the class. Do let me know please. I'm reading the chats. Do let me know how's everything going on. Having fun with code? Mark your attendance. I'm waiting for the names in chat. I'm waiting for the names. Okay, cool, yeah, cool. We'll continue. We already know that the series will cover in 150 days will cover all the possible topics of the computer programming, like for the DSA, especially for the problem solving. No matter in which computer coding interview you sit, but you will have a good understanding after the series, right? So we already completed the math series, and all of you were there. I'm glad. And again today we'll see another question which already has been asked in Amazon, Apple, Bloomberg, Facebook, Microsoft, and Google repeatedly. The question is find peak element. So we'll go to the LeetCode and we'll understand what is the problem statement, how we can solve this. Okay, cool here. But keep interacting. Do let me know I'm audible to all. Do let me know you're enjoying the things you're understanding or not. Cool here. I'll search LeetCode here. Now, why it's saying sign in? Guess I was already signed in. Okay, cool, yeah, cool. We'll sign in again. Cool. Now we'll search for the problem statement. And where are the regular people? So I can't see the names. Is this glitch at my side or at your side as well? Cool, yeah. I'll search for the problem statements. I'll go to the problem section. Not explore. I'll go to the problem section. Cool. Not here. Problems. And here at problems we'll see what? Now cool. We'll search find peak element. Trust me, this question can be edgy, this question can be tough, and this question can be like if you have written the solution that is also not applicable. So what is something pretty amazing in this, we'll understand find peak element. If there's a possibility that you write a solution which is not applicable. Find peak element. Maybe in suggestion we'll get this peak element. Find peak element. Success rate 46.3, which is very less. But let's see. Okay, let's see how we can solve this. Cooler, it's being loaded now. Now read the problem. So whenever you see any problem in any kind of interview, just remember that you need to read the problem statement very carefully. Even you understand the problem, somehow you'll figure out the logic. But if you don't understand the problem, you won't be able to make any kind of logic. So let's understand what is peak element. Peak element is an element that is strictly greater than its neighbors. You understand the peak, the mountain peak, right? Which means that is greater, that is strictly greater than its neighbors. So let's say this is a peak. This is a peak, right? Which means that all the mountains at the left and right will be smaller. Yes, no. So that is a peak. Now Given a zero indexed integer array nums, find a peak element and return its index. So what we have is that we already has given a nums as an array. Our job is to find a peak element and return its index. So you don't have to return an element, you just have to return the index of peak element. Cool, yeah, we understand this. Now if the array contains multiple peaks, return the index to any of the peaks. Let's say there are multiple peaks, you can return any of them, this is fine. Now you may imagine that they are saying that, listen this carefully, okay, maybe you are getting trouble in understanding this. They are saying you may imagine that nums minus 1, which means the element at the left side which is not present, and again nums n, which means the element at the right side which is not present, because you know n is not possible as an index if n is the length of the array, right? That's the out of index. So that you can imagine minus infinity means very, very small number. Again, in other words, an element is always considered to be strictly greater than its neighbor, than a neighbor that is outside the array, which means that if particular element is not in the array, so the starting and the ending element you can consider as a peak. Okay, so now let's understand this problem statement. So for example, look at this. Is 1 is peak? No. Why? Because at the right side 2 is greater than the 1. So 1 is not peak. Is 2 is peak? No. Why? Because at the element the right side is greater than the 2. So 2 is also not a peak. Is 3 is a peak? Yes, 3 is a peak. Why? Because the element at the left side and the element at the right side are smaller. Okay, are smaller. So now we understand this again. So we understand what is peak. How we can implement this solution? Let's go to the slides. I'll make you understand how you can solve this problem. Okay, how you can solve this problem. So first basic approach, what it can be? Tell me. First basic approach, what it can be? First basic approach can be. First basic approach can be. Let's say we have an array nums, and I'm assuming nums as previous 1, 2, 3, 1. Let's say this we have. So now again, tell me one thing. This nums can one thing. Another I'm taking. Let's say we have nums, which is 3, 2, 1. Again, I'm assuming we have another nums, third number. 3 examples I want to tell you. Okay. So I'm assuming, let's say we have 1, 2, 3. Tell me which are the peaks. In this, we can clearly see that left and right elements are smaller than the 3. So which means 3 is the peak. You need to return the index. So index of this 1, 2, 3. So the output should be 2. Why? The index is 2 of 3. Cool. Again in this. You remember that condition? Where they have mentioned especially that if there is no element at left, you remember nums n minus nums minus 1. You remember? Right. So again, you know that all the left element will be the smaller than this. Again, if the right element means this element is smaller than the first element, which means this is peak. So here the peak is 0 at 0 index. Yes or no? Peak is 3 and the index of this is 0. Again, look at this. If the right element at the left rightmost element is greater than its previous one, then it's a peak. So tell me, what are the conditions? Here the first condition is that that if something like, we can say, if nums 0 means that element 0 index is greater than the nums 1, then we can say what? 0 is peak. Yes or no? Here we can say, like, let's say I'm assuming the length of this nums is n. So now I'm assuming, if this is the length of this nums is n, so now I'm assuming that if what? N minus 1 nums n minus 1, which means this element, if this is greater than nums n minus 2, then can we say this is a peak element because this is greater than its left one, and at the right there's nothing which is smaller. We already consider it, right? So now we can say what? Then we can say n minus 1 is peak. Cool. But what if there's only one element? I'm telling you, solution number 1, the basic approach, brute force. The basic approach, brute force. How you can attempt this, right? If, let's say, I don't have a lot of understanding, so how I can read a problem and how I can make the solution, then it comes to the optimized one. Okay, so now here, what if in nums there is only one element? Means the nums dot length is 1. If there's only one element, so we can say it's itself, it's no, it's itself is a peak, right? Because if there is no mountain, the mountain itself is a peak. Yes or no? So then we can say in this case, peak will be zero. Peak will be zero. So we understand these three scenarios. But what will be the scenario of this? I'm assuming the index of this three will be I. Okay, so I'll write this nums I. This nums I should be greater than what? Nums I plus 1, nums I plus 1, which means the element the right side should be smaller than this. And again, as well as nums I should be greater than the left one, nums I minus 1. If the both conditions are true, we can say peak is I. We can say peak is I. Yes or no? Right? Because any of this element and this element are smaller, then we can say the middle element is a peak. That is a basic brute force we can write. Right? But I'll tell you, if you write this solution, why this is not applicable. You'll understand. I'll write the code for you. You'll understand that we can also make this as a solution. And this will work fine on the LeetCode. But again, this is not an applicable solution. But why? The question is why. So what we'll do is that we have already thought, like we had few cases, like I'll define the length or something, like if nums dot length means we have single element. I'm assuming the first condition that if we have length equals to 1, which means we have single element, then what should be the peak? The zero index, because single element has an index at 0. Again, can be scenario that if nums 0 means the first element is greater than what? Nums 1, right? So in that case, what we should run? Again, the peak will be 0. Peak will be 0. Again, there can be a scenario, we assume that the rightmost element is the peak. So that can be seen like if what? Nums dot length minus 1, because last index is nums dot length minus 1, right? If this is greater than nums dot length minus 2, then we can say the rightmost element is peak. Yes or no? So we can return nums dot length minus 1. Yes or no? We can return this. And again, if this is not the scenario, which means we don't have a single element, the first element is not a peak, the last element is not a peak, which means there is a peak exists in the middle, in the between. So we'll write the logic for that as well. So let's say, because 0 we already checked, so we'll start from 1, and I should be less than, because we also check for the last, so we don't have to go till there, right? Nums dot length minus 1, because that we already have checked. Yes or no? So we don't have to run till the last element of the array. Again, I plus plus. So condition was like if our nums I, the current element, if this is greater than what? If this is greater than, it's the left element, means nums I minus 1, nums I minus 1. If this is greater than, it's the left element, and parallelly this is greater than, nums I is greater than its right element. Make sense? Greater than its right element, I plus 1. So in this case, can we say nums I means that I, not nums I. Nums I will be a value. We need to return index. I will be the final output. And again, at the end, when the loop finishes, we can say if we didn't get anything, we can return minus 1, because that will never be a scenario. Trust me, that will never be a scenario. But still, okay. Still, good evening, EX. I said just now joined whether this problem is come in TCS and QT exam. This is possible, Mohan. This is possible. It can come because So can you please provide me the stuff free to prepare for TCS and QT? You can search the previous year paper of. Can you please list of the question you following? Okay, Santosh, I'll try. I'll see if I can provide you. Okay. Cool. Yeah, cool. So now let's run this. Let's run this and let's see it's working or not. Okay. Again, Mohan, if you are preparing for the double time we have written this, remove this. If you're preparing for TCS NQT, maybe this problem can be very helpful because this is the label of the TCS NQT. All the problems that I'm covering will help you for cracking. Hi Yogesh. Okay, but it's working. It's beating 100%. But why this solution is not applicable? Can somebody tell me why this solution is not applicable? Even if it's running fine on the LeetCode itself, but still this solution is not applicable. Why? Because the time complexity you see in the worst case scenario, you have to iterate the whole array, and the length of the whole array will be n, which means the time complexity of this solution, this approach will be big of n. And they have written, you must write an algorithm that runs in log and time complexity. That's why this brute force will not be applicable solution. Then what will be the applicable solution? Okay. Santosh, I'll see if I can. Okay. Cool, yeah, cool. So now here, we know that because this solution is not applicable. Why? Because this will take a time complexity of big of n. Anyhow, we are running the whole loop till n, right? And the space complexity is constant, which is fine because we are not using any extra data structure here, right? Cool, yeah, cool. So now here, what we can do? Anyhow, now we have to find another logic. How we can think about what are the logics are possible? Go to the topics part. Click on the topics. You'll see that this question includes the topic array and binary search. So now you're concentric that you have to think around binary search. You don't have to think around on all the concepts. You just have to think around binary search. So now let's see, can we do this through binary search? Can we solve this problem through binary search? Because binary search at time complexity of log n. Now we are doing from the linear search, which is not applicable anyhow because they want in log n time complexity, and we have the big of n. So let's see. We'll go to the slide part and we'll understand that is this possible to solve this? Is this possible to solve this in log and time complexity? Okay. So now we come to this approach number 2. Approach number 2. I guess this is a page number 3rd. Approach number 2. Approach number 2. Okay. So what will be the approach number 2? Approach 2. Binary search. Binary search. But how this can work? Let's see through the examples. So we have nums. The value was given 1, 2, 3, and 1. So if we apply the binary search logic, you remember what we used to do is that, what if array is not sorted? Yogis, even if array is not sorted, binary search will be applicable. That's what we are going to see. Okay, that's what we are going to see. Because anyhow, you cannot sort this array. Because if you sort this array, you'll change the index of the peak. So you cannot sort this array. So now here let's assume this is the left part. That's what we do in binary search, yes or no? And this is the right part. In binary search, we calculate the right. We calculate the mid. So now tell me what will be the mid? The mid will be left plus right by 2. Left plus right by 2. And this formula is applicable because the length of the nums is very less. I'll show you somewhere. I'll show you, don't worry. Okay. So now here, let's see. As of now, left is 0. At starting, the left is 0. And right is what? The length minus 1. So the length is 4. So right will be what? Right will be, we have the right as what? As 3. And left as 0. Cool. So now put the value 0 plus 3 by 2. This becomes 1.5. If you convert this in integer, then this will become what? This will become 1. So now the mid is 1. Okay, mid is 1. And at the 1 index, we have value as 2. So now if this is coming, so we have to see, we have to check like this is a peak or not. So how we can decide? We can decide by doing one thing. What? Is this mid greater than its left or right? Right, that's what we have to do. So now let's see, we have to check the condition. Condition is what? Our condition is that mid, right? We have to check if that nums that mid is greater than nums mid plus 1. Means is this greater than the value of its right? right? For checking the peak, yes or no? And if this is greater, if mid is greater, so can we say peak exists at left side? If mid is greater than mid plus one turns to right. Mid plus one means right. And if mid is greater at the left side, so can we say peak exists at the left? So if peak exists at the left, what you have to do, you have to, sort the array. You have to optimize the array, the length of the array, the length of the targeted area. So that should be right. Then you'll update right equals to mid, which means that you don't have to search at the right side. You just can see at the left. So one condition. Again, tell me what we were doing in the binary search. If this is not the scene, then in the else case, we were moving left to mid plus one. Left to mid plus one. And I'll show you how this solution will work. You don't have to worry about. I'll show you how this solution will work. Right? So now tell me one thing. Now tell me one thing. What will happen here? What will happen here? You remember in the previous page? You remember from the previous page what we had? We had mid equals to one, which means that we have value of this nums mid as two. So nums mid we had one, and which is two, nums mid plus one, which is three. Yes or no? Nums mid plus 1, mid was 1 plus 1 becomes 2. At the second index we had the value as 3. So now tell me, is this correct? Is this true? No. 2 is not greater than 3, which means this is false, which means we have now we know that. Now if this is not the true, which means value does not exist at left, we have to move the left. That's what we were doing in the binary search, right? So now tell me what will happen. We'll update the left. So the value of left will be mid plus 1, and mid was 1, so 1 plus 1 becomes 2. So this is 2 now. This is what? 2 now. Again, let's see. While loop will execute again. You remember in the while loop, we were writing the while loop. In the binary search itself, right? So now in the while loop, we'll see, while we'll check, is this left is less than right. You remember the binary search, right? If this left is less than the right, then what will happen? We'll execute this loop again. Tell me the value of right. The value of right is 3. The value of left is 2, which means 2 is less than 3, which is true, which means calculate the mid again. So calculate the mid again. So at the step second, we'll calculate the mid. The value of mid will be left plus right by 2. So the left is 2, right is 3 by 2. This becomes 5, right? And again, what you will do is that you will write 5 by 2, which means 2.5. In integer, we can say this is 2. So tell me at the second index what we had the value. At the second index we had 3. Yes or no? So now tell me what will happen. You will see the condition here. So nums mid as second index, which is 3. Is 3, tell me one thing, is 3 greater than, I'll change the color to make you more understand. Is 3, like, because if mid is 2, if you put the mid here 2, so the value of this will become what? 3 at the second index. Yes or no? So now here you see mid plus 1, which is what? Mid plus 1, which is 2 plus 1, means third index. And at the third index we have 1. At the third index what we have? We have 1. Is 3 greater than 1? Tell me, is 3 greater than 1? Yes, 3 is greater than 1. 3 is greater than 1, which means this if condition will execute. And tell me one thing, if this mid is greater than the right part, which means you don't have to search at right. All the value exists at left. Peak exists at left. So what you will do? You'll update the right. So right will be the mid. So value of right will become here. The value of right will become what? The value of right will become 2, because the value of mid was 2. Right? So now tell me again, while loop execute. Is left less than the right? No, this is not. So which means that while loop will not execute. So what will be our output? In this case, either right or left, both are pointing to the peak. If you see that left is also 2, right is also 2. So when the scenario will come by applying this algorithm, when left and right both are equal, that will be the peak. Okay, so at the end, either we return left or right, that will be a peak value. But again, there is a scenario. What if the if that mid plus one, or we can say the last element we are pointing out. So do we need to perform that calculation? We'll see this. Okay. So now I'm going to open the VS Code, that our LeetCode again, and we'll write the code. Okay, we'll write the code, and then again I'll try run this. Okay, again I'll try run this. I hope you'll get this. You'll understand this, how this whole is working. Cool. So now here I need to define left was 0. You are assuming, yeah, every time I cannot write nums.length. So you know what I'll do? I'll define a n for the length of the nums. So n equals to nums.length. Cool. Now I'll define the right. Right will be length minus 1, which means n minus 1. Yes or no? We have to run a while loop to implement a binary search. It will run till left is smaller than the right. Smaller than the right. So now here we will calculate the mid. So calculate the mid. Mid is equals to left plus right in the bracket, and by 2. And this left plus right is applicable because the length of the array is very short. Otherwise, there is another method to calculate the mid. And I hope those have learned the merge sort, they know the concept. So again, I write the condition. The first condition can be like, there will be a one scenario also. What if that nums, we can say that it's pointing out to the last element, so we don't have to run this again. So we can say if nums mid minus, or directly we can say if mid is equals to n minus 1, which means that mid is pointing to the last element of the array, so we don't have to execute anything. That time the 0 index value will be our final output. Again, I'll write here if nums mid is greater than, it's a right value. So mid means nums mid plus 1, which means that we have to update the right because we cannot find the value at the right side. So right will be the mid. Again we can say if this is not the case, so the else part, if this is not the case, which means the value exists right side, so we have to update the left. If value exists right side, so we have to update the left. So left will be what? Left will be a mid plus 1. And at the end, either you return left or right. Both will be the correct output. Why? Because this scenario will only come when left and right are equal. Otherwise, this while loop will keep running. And there will be a scenario when left and right both will be equal. So let's run this. I'll show you. Either you return left or right, both will be correct. Why? Because the scenario will come only, you will find the peak when left and right both are equal. Because when left and right both are equal, only then that is a scenario. Then all the left element and all the right element were smaller than the current element. Okay, so it's working 100%. It's beating 100%. Okay, I'll try with the right. Okay, I'll try with the right, and this is the one of the best possible solution. I'll try with the right. So now let's see why, because this will be only scenario when left and right both are equal. You see, it's beating 100%. Cool, yeah, cool. I hope you are understanding or getting the logic. Sure, I'll do a dry run for this as well. Okay, so don't worry, I'll do a dry run for this as well. Now, what I'll do, I guess I should copy the code or something to paste on the PPT to make you more understand. So I'll copy this solution here. Okay, I'll go to my PPT and I'll save this, probably keep, and probably I can paste it here somewhere. Right, I can paste it here. Insert, can we have text, a text box? If we can have, so I'll place the solution here. Oh, this is coming black. No worry, we'll change the text color. Control A. I'll change this text color to yellow. Cool. You're able to see the solution, right? Again, I'll do a slideshow from current slide. This is the solution that we have written. Now let's see, let's understand how this will work. Again, we'll understand how this will work. Okay. What I'll do is, what I'll do is, here I guess colors would be, in colors would be what? White or something? Because white is also fine, right? So now here at step number one, okay, at step number one, tell me the value of left, which is 0, value of right, which is length minus 1. Length minus 1, I'm taking, let's say, input, we have input as nums, and which is 1 comma 2 comma 3 comma 1. Okay, again, and now right will be the length minus 1. The length of this is 4, so 4 minus 1 becomes 3, right? So we know the meaning of this. Now again, is while, this while means left is 0 less than 3. Yes, it is. And if this is the case, which means the while loop will execute, we will calculate the mid here. We will calculate the mid. What will be the value of mid? Tell me. 0 plus 3 by 2, which means 1.5, which means in Java this is 1, because anyhow you will avoid the decimal value after converting into the integer. So now again we are checking, like, is this the last element? Is mid pointing to the last? Because it's pointing to the last, which means the first element itself is a we can say that is a peak element, right? Because that is scenario when we have a single value. So now cool, now cool. So now here this is not a scene, right? Mid is not equals to the n minus 1, because mid is 1 and 1 is not equals to what? 4 minus 1, which is 3. So this is not scenario, which means we don't have an array of one size, we have multiple elements. So now here, come here, we'll see if peak exists in left or right. So if mid is greater than the right value, which means peak exists at left. Okay, so now we are checking here condition that if nums mid is what? Mid is as of now 1. So at the 1 index, what we have? We have 2. It's 2 greater than mid plus 1, and mid is 1, 1 plus 1 becomes 2. At the second index, we have 3. Is this true? No, this is not true, which means else will execute. Else will execute, which means left will be incremented. So the value of left will be what? The mid plus 1, and mid was 1. So 1 plus 1 becomes 2. So value of left become 2. We reached the end of the loop, which means while loop will execute again. So step number 2. Step number 2. It will see is left less than the right. So value of left is 2. The value of right is 3. Yes or no? So is 2 less than 3? Yes, it is. So now tell me what will happen. We'll calculate the mid again. So the value of mid will be what? The value of mid will be left plus right, which means 2 plus 3 by 2, which means 5 by 2, which means 2.5, which means 2. And I've told you this solution will only work when left and right both are equal. That will be the exact scenario when you will get the peak element. Let's see how this works. Okay, now we have mid as 2. Now tell me, is this mid equals to n minus 1, length of the array, which is 4, 4 minus 1, 3. Is 2 equals to 3? No, because we have more element. It's not a single element, right? So now this will not work. Again, who will work? The if will work. Again, let's see that mid which is 2. So nums 2 is nums 2. The value of nums 2 is what? At second index, which is 3. Is 3 greater than mid plus 1, which means 2 plus 1, which is 3. At third index we have 1. Is 3 greater than 1? Yes, it is, which means update the right. By update the right, if mid is greater from its right element, which means peak exists at left. Yes or no? If peak exists at left, so we have to squeeze the size of the array. So we have to update the right pointer. You remember the binary search? So now what you will do, you will have update the right. So the value of right will become mid. So which is mid is 2. So now left and right both are equal. If this has been executed, else will not execute. We reach the end of the loop. We'll come here at the while part. While part. So step number 3. What will happen? Left is 2 and right is 2. Okay. And again, if both are equal, which means while is false. While will not execute. If while will not execute, will return anything, either left or right, because this will be your only scenario when left and right both are equal. So either you return right here or either you return left here. Both will be the peak element. Look at this. At second index, we have the peak element. And how this came? Because first time we have targeted, if mid was greater than the right element, which means that we have to update this. You remember? This mid was greater than the right element. So which means you don't have to search at the right, because maximum value cannot exist there. So again we have updated the right pointer, and there will be a scenario when left and right will keep updated and they will meet at the same point, and that same point is the peak element. Okay, that same point is a peak element. To understand it more, what you need to do is that you need to try different test cases which already has given, and you have to do it right in the same case. Okay, and this is a possible, and this is the best applicable solution. That basic, that brute force approach is not applicable. And can somebody tell me what is the time complexity of this? Time complexity. Every time the input size, which is dependent on the mid, right? We are dividing by 2. So if every time the input size is being divided by 2, that time the time complexity will be log n, log 2 base n. Basically, we write it what? We write it log n, big of log n. And the space complexity SC will be constant because we are not using even a single data structure. Cool. Yeah, is this clear now? Do let me know if you have any particular doubt. Do let me know, please. Okay, actually, this part I guess this is hiding. Right. So I'm writing it somewhere else on the new page, maybe. So the time complexity TC, the time complexity will be what? The time complexity TC is log n, because every time the size of the input is being reduced by half, and the SC will be big of 1. Why? Because we are not using any extra data structure. Not even we are defining any extra array data structure. And why it's log n? Because every time input is divided by half, because everything depends on the mid. Cool here, cool. I hope it's clear to all. I hope it's clear to all. Do let me know if you have a particular doubt. Then we can continue. Otherwise, we can wrap. Otherwise, I guess we can wrap. Okay, then I guess bye bye to all. And again, those are having TCS and QT. These questions are super important for them as well. Okay, any kind of good coding exam, any kind of good coding exam, the problem solving will help you a lot. How to attend a problem, how to calculate time and space complexity, how we can say it's optimizable or not. Okay, bye Sanket, bye bye all, bye bye all. I'll wrap this.